And then here we're going to get equals x plus 3x minus 3. And then we get 4x plus 12 minus 2x plus 6. And then we're going to get 1 over x plus 3x minus 3. The left-hand side's a full fraction. The right-hand side, we're going to have x plus 3x minus 3. 4x plus 2x, 4 xylophones minus 2 xylophones, sorry, it's 2. And then 12 plus 6 is 18. Now, we have this denominator same as that denominator, correct? Then we can say that this numerator equals this one. But before we state that, what do we have to do? Yeah, our restrictions, our NTVs. So we're going to have over here x can't equal plus or minus 3. Correct? And we'll always check for extraneous roots, because if they are that, we have an extraneous root. All right. So we have 1 equals 2x plus 18. Subtract 18 because it's linear. Negative 17 equals 2x. Divide by 2. X equals negative 17 over 2. And then we follow behind with x can't equal plus or minus 3, which it doesn't, so we're good. Okay? All right. Everyone pick up a calculator. What is negative 17 divided by 2? So you can use the fraction, but the y one. If you don't, you're going to have to go numerator in brackets divided by denominator in brackets. So that's y1. y2 would be full fraction 4 divided by x minus 3, close the bracket, show it's a fraction, minus, open the bracket, 2 divided by x plus 3 to show it's a fraction. So you have to find out where it intersects. We're looking for negative 8.5, correct? So our window has to at least have negative 8.5 in it. Can you go to the window? So you need to have at least your x min be negative 8.5, right? So negative 10 is fine. If you have your normal standard window, that's good. Okay? My computer, oh my gosh, something is wrong with the computer. So if you go second, trace 5, make yourself close to the part of the graph that is near negative 8.5. So you're going to have a really weird graph. It'll have like some weird things like this and that, whatever, right? You need to go close to negative 8.5, somewhere over there. So get yourself over to that part of the screen. And then go second trace 5, enter, enter, enter. Second trace 5, enter, enter, enter.
Second trace 5.
So you need to be close to negative 8.5. If you're erroring, it's because you're not here. Second trace. Second trace.
I'm smarter than you come
Yours is not generating.
1 times 37.
odd. 1 to 37 odd.
Oh, so you're in the question door.
Yeah. Jack now. Oh yeah, he's like his dad walked in. That's fine.
You know that story?
Oh, Marlin.
No, his dad walked in the room and he was sweating. He's like this actual. And then after that, dude, I'm supposed to do my rules are so long.
Yeah.
You're trying to find out where they intersect.
Like a space.
Up in the basement.
I use like an actual space. One of these are
So this is to check and see if our answer was right, correct? We did y1, y2, and then we did second, trace. And the reason why we press trace is because when you press the second button, you're actually doing the word above it. So what's the word above the trace button? Calc. Second trace, the word above the trace button is calc. So you're calculating where these two graphs intersect, which is number 5. And then you're hitting enter 3 times, not enter 3 in multiplication sign, enter, 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 right? And then it finds out where they intersect. And they intersect at negative 8.5. So I know I'm right and I move on, correct? Like I feel confident in myself. So the calculator is a good way to check your work to see if you're right in a multiple choice or whatever too. Okay? I understand typing them in isn't the easiest. Okay, let's look at F. So we distribute the top, we get x minus 3 over x minus 3 plus x over x minus 3, quiet please, equals x squared minus 2x over x minus 3. All right, so this here has x minus 3. And then the top is x minus 3 plus x equals x squared minus 2x over x minus 3. And so then we're going to get x plus x is 2x minus 3 all over x minus 3 equals x squared minus 2x all over x minus 3. And so we have this denominator equals this one, then I can say this numerator equals this one, right? We always get to this point. Well, hopefully you get to this point. All right. So now, before I get rid of those denominators, I have to say x can't equal 0 or 3. Everyone's paying attention? All right, so then we have 2x minus 3 equals x squared minus 2x. And when I have an x squared, what do I always have to do? Get everything 2? One side set equal to 0. So I minus 2x, add 3. And I get 0 equals x squared minus 4x plus 3. And then I can do this one of 2 ways. I can factor. Factoring doesn't always work, but for this one it will. I say what times what equals 3, what plus what equals negative 4, and I get negative 3, negative 1. And because I have a 1 in front of my x squared, I can go right to brackets. I get x minus 3, x minus 1. If I don't have a 1 in front, I have to do decomposition. So I get x minus 3 equals 0. I can't skip the step. X minus 1 equals 0. X equals 3, x equals 1. This one is extraneous. And this one works. The other thing I could do is quadratic formula. 1x squared minus 4x plus 3 equals 0. The quadratic formula is in the very bottom left of your formula sheet, which you should all have one because I gave it to you at the test. It says for the form ax squared plus bx plus c equals 0. It literally tells you have to set it equal to 0. Correct? Like here, it tells you exactly that. So it's ax squared. So my a is 1. My b is negative 4. My c is 3. So I get x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 3, which we've discussed this already, correct? Very beginning of the semester. I was going to say season, but not true. And then 2 times 1. So x equals negative 4 plus or minus, and I told you to do what's under the square root next. So I get 16 minus 12, which is 4, over 2. Then if that's a perfect square, which it is, the square root of 4 is 2, over 2. And then this splits. So I get x equals negative 4 plus 2 over 2. and x equals negative 4 minus 2 over 2. So this one's negative 2 over 2, which is negative 1. And this one's negative 6 over 2, which is negative 3. It should be positive. So let's go.
B positive.
B is negative. So this is, oh my gosh, why did I write a positive? Oh, I have a negative, but do you see how it got stuck with my equal sign? Rip off. Okay. So this becomes negative a negative b, so it's plus. This is negative 4 squared, so it still ends up with 4. So I'm going to get 4 plus 2 over 2, x equals, which is 3, x equals 4 minus 2 over 2, which equals 0. This one is extraneous. So this one, the extraneous one, will not show up on my calculator when I find the intersection. This one will. X equals 0. Anyone? Bueller? Man, this is going downhill. That's why I factored. I saw the 0 down here and wrote it. I don't know if this will happen. Okay, so we're typing this one into our calculators. Go. Y1 is the first half. Y2. Go. Where should the intersection be this time? What's the answer? 1. So we're going to get close to 1 and then go secretary's 5, get close to 1, enter, 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 right? Try it out. Did everyone get 1? All right, let's go over this one. So this one we have to put the 21 in, so we get 21n minus 84 over 21n times n minus 4, so we have a monomial binomial denominator, plus 21n over 21n n minus 4 equals, and I told you to put the 10n together first, so we get 10n squared minus 40n over 21n n minus 4. So in this one I get 21 plus 21 is 42 minus 84 over 21n n minus 4. And then this one I get 10n squared minus 40n over 21n n minus 4. So my non-permissible values are 0 and 4. So then, once I have them written, I can say this equals this, so this equals this. And I get 42n. 42n minus 84 equals 10n squared minus 40n. Still have to get it all to one side. It's not an option to not choose to do that. So you get 0 equals 10n squared minus 82n plus 84, which is sometimes overwhelming. But I can do what? Let's get a 2 and knock it down a little. So I get 5n squared minus 41n plus 42. And then if factoring is overwhelming, what can we do? Nope. I know what you're thinking, but no, not called that. Quadratic formula. So this would be my A, this would be my B, this would be my C. So I get x equals negative a negative b, so 41 plus or minus square root of negative 41 squared minus 4 times 5 times 42. In the quadratic formula, this goes nowhere, just so you know. You take a GCF out. And then you get all over 2 times 5. So x equals 41 plus or minus something. I don't know 41 squared in my head. I'm impressed with myself if I did, but I did not. It comes up to 16 under the square root. No?
It would be 1681 minus 840.
1681 minus 840.
Double check.
So x equals 41 plus or minus what? Root.
841.
841. Does 841 break down into any perfect squares? I believe so.
Is it? 7?
Okay, that's as low as it goes. So this would be the exact values. And you'd say x, not x. And this isn't an x, that's a typo. What should this be? N. N equals. And then n can't equal 0 anymore. If they ask for it for a decimal, then you break it down. Yeah.
You can square root it into 29.
It's a perfect square?
Yeah.
Ah, that's what I asked. Is it a perfect square? And everyone's like, no, no. You did? Quietly?
No, he said it to me.
I
He
know
said
it's,
it to
yeah,
me.
he like whispered
That's
it.
pretty loud.
You said it to Eamon?
Yeah.
Oh, I said it like that.
David really.
I know, I'll back him up. He said,
Mm.
Mary probably heard.
I know, I did.
Mary doesn't.
Root 841 is 29.
Are you?
Oh wait, so this one would factor 41 plus 29 over 10. And then 41 minus 29 over 10.
That's been there.
What does this one become?
7.
Yep, I guess it rhymes with heaven. What does this one become? And they're both good because they're not non-permissible values. Okay, you guys are going to grab your workbook.
What? I told you I was right.
Grab a workbook.